Okay, in this video we want to look at a problem where we have to take the derivative using of an inverse tangent of a variable. And here we say y is equal to the inverse tangent of x minus 1 divided by x plus 1, and we want to solve this for dy dx. So we have it set up as, let's see, dy dx that is equal to, now if we're taking the inverse tangent of some variable, say u, and then we want to take the derivative of this with respect to x, that would be equal to 1 over 1 plus whatever this function is or variable is that we're going to take the tangent of, is that squared, and then we have to take the derivative of that with respect to x. So applying that formula to here, this is what we're taking the inverse tangent of. So this quantity right here, that's the equivalent of u up here. So we're going to write this as dy dx will equal 1 over 1 plus u squared. And this is what u is, so we're going to have 1 plus x minus 1 divided by x plus 1 quantity squared. And it is 1 over that. 1 over 1 plus the u squared, this is the u. And then we have to take the derivative of u with respect to x. So we have to take the derivative of x minus 1 divided by x plus 1, take the derivative of this rational function here with respect to x. And that will be the dy dx. So let's deal with this part first here and get this algebra out of the way. This here would be 1 over 1 plus, let's see, let's write this as, look at this part first. Let's write this as x minus 1 squared. We're going to write this now. Look at this quantity first. This will be 1 over, this should be x1, x minus 1 squared divided by x plus 1 squared, and we have to add 1 to that. So let's, since this is in the denominator, let's write 1 like this, x plus 1 squared divided by x plus 1 squared. So I have this quantity squared, which is this numerator squared, divided by this denominator squared, and I have to add 1 to it. And this is 1. So let's see, this will equal 1 over this plus this divided by this. So we would have x plus 1 squared plus x minus 1 squared divided by this common denominator, x plus 1 squared. Or 1 over this would be the same thing then as multiplying by the reciprocal of this. So we can take this upstairs to the numerator and write it like this then. X plus 1 squared, and take it away from here. So far, all we are doing is just manipulating the denominator right now. Okay, and let's see. We're going to multiply these out and see if it helps us simplify things, because here you see you have a plus 2x, and here we have a minus 2x when we multiply out. So this would be, leave the numerator alone for right now. This squared divided by x squared plus 2x plus 1. And then here we have plus 2x plus x squared minus 2x plus 1. So let's see, this will equal x plus 1 squared and here we have x squared plus x squared. We have 2 times x squared plus 2x minus 2x. Those cancel. We have plus 2 here. So it looks like this will equal x plus 1 squared divided by 2 times x squared plus 1. Okay, so 1 over all this stuff comes out to equal this. So this is this. So let's rewrite things. This will equal x plus 1 squared, quantity squared, divided by 2 times x squared plus 1, and then this is now this. We've done the algebra to transform this into this. Now we have to do the calculus. Now we have to take the derivative of x minus 1 divided by x plus 1. So let's see. This will equal, this part stays the same, x plus 1 squared divided by 2 times x squared plus 1. And now for this derivative, it's going to be, this is a quotient, so it's going to be x plus 1 times the derivative of this minus x minus 1 times the derivative of this, and all that's going to be divided by x plus 1 quantity squared. So first thing is we have this x plus 1 times the derivative of this with respect to x. We should write it like this, dx. Well, that's just going to be 1 then. We have this times the derivative of this. That's going to be 0, of course, so we're just going to have dx. So that's just this times 1 minus this x minus 1 times the derivative of this. That's going to be 0, and it's just going to be dx over dx, so it's just going to be 1 divided by the squared. And what does that leave us? Looks like these are going to cancel. And what do we have from here? We have x minus x, so those are going to cancel out. And then we have 1 minus negative 1, that's 2. So this whole numerator up here is just 2. So what do we have left? We have 2 divided by 2 times x squared plus 1. Those are going to cancel, and we just have 1 over x squared plus 1. And that's it. There's nothing else left to do. So we're here then, if we have this, the inverse tangent of x minus 1 over x plus 1, then dx of this, that equals 1 over x squared plus 1. And that is it. So again, it took us a while to get there. As you can see, it's not really a difficult problem, but first we had to contend doing this algebra right here. And when we did that, this became this right here. And then we had to take the derivative of this. This is where the calculus came in, was in this step right here. But that wasn't too difficult to do. And once we did that, things just reduced straight down to our final answer here. So that's it for this problem. Come back and join us for some more videos, and we'll see if we can work some more problems.